In the second part of video 3.2, we will focus on the type of information needed to complete the basic wildlife population model. In other words, let's ask the question, what population information do wildlife managers need to understand and develop sustainable options for harvest management? By addressing this question in more detail and looking to the best available information and knowledge, we are then able to incorporate these data into computer simulation models. 5 age classes were defined in the model. This table shows the 5 different age classes for females: young of year, yearlings, young adults, mature adults, and old adults, and their corresponding age categories in months or years. The photographs show examples for each of the age classes according to 4 species, including grizzly bear, caribou, moose, and Dall sheep. Males for each of the 4 species were also categorized according to the same 5 age classes as the females. To develop preliminary estimates of natural mortality and survival for the different species of wildlife, we reviewed general scientific research reports and papers on relative importance of predation, diseases, density-dependent and weather-related mortality. We used that biological information to provide a range of values for survival rates for each of the 5 age classes across the 4 wildlife species. The main point to see in this table is, as you look from left to right across the age class columns, there is a general trend in survival rates that shows young of year animals have the lowest survival rates of the 5 age classes. The range of survival values improves for yearlings, but are highest in young and mature adults. As animals become old adults, the survival rates start to decline and become more variable. This table shows basic information on the production rate of newborns by adult females according to their age class and species. Note that the age at which they first have young is different for each species. For example, we generally think that female grizzly bears don't have their first cubs until they are 5 years old. In contrast, yearling female caribou and moose can breed if conditions are good. For Dall sheep ewes, age of first breeding is generally 2 years, so they have their first lambs as 3-year-olds. You will also note that newborn production is generally highest in prime-aged mature females. Also worth noting is that adult cow moose are able to produce twins, so when grouped across all cows in an age class, the average production can be greater than 1 calf per cow, that is, greater than 100%. For the purposes of entering information and running a basic landscape and population model, we pooled all harvesting by people into one group. So although in reality there may be different harvest levels by user groups, for simplicity we just modeled harvesting by all users as one value. To emphasize this basic approach, for this example we also set the other types of human-related mortality such as roadkills, predator harvest and trapping, removals, and poaching to 0. In summary, I would like to leave you with 2 main points. Firstly, wildlife live in dynamic landscapes that change due to natural disturbances and human land uses. It is important to consider these natural and human-caused changes in the landscape because the resulting habitat changes may affect population trend and influence options for sustainable harvesting. However, for our modeling exercise, we chose a remote study area and assumed that there was no human footprint or significant land uses, so that subsequent model simulation runs would emphasize the fundamental dynamics of wildlife populations. Secondly, wildlife population models are often built upon estimates of birth and death rates, population size, and trend. This information is often collected by biologists and can be used to inform models. Indeed, input from area biologists and local users is critically important for evaluating and confirming modeling results, especially when models are used to help evaluate management options. Thank you for your interest. Please view video 4.1, where we will explore habitat variability and moose harvest management strategies.